Hi everyone, we are on part 2 of the derivative rules, the product rule. Okay, so I want you to consider the following equation. So 3x to the fifth equals 3x cubed times x squared. Hopefully you agree with me that that works, right? When we have same bases, we add exponents, so we can break up 3x to the fifth into those two chunks. So in English, 3x to the fifth can be written as a product of 3x cubed and x squared. Now, last section for the sum and difference rules, we just used the power rule for each term and then added or subtracted the individual derivatives. Okay, let's see if this works for multiplication. Okay, so that would be taking the derivative of each chunk and then multiplying and see if it equals. Okay, so let's have a look at the three individual parts to that above equation. So 3x to the fifth. So let's see if we can find the derivative of that. The 5 comes down, so that's going to be 15x to the fourth. Okay, let's try the next one. So 3x cubed, so that's going to be 9x squared. And then the derivative of x squared would just be 2x. So let's see if the logic that worked for the sum and difference rules works for multiplication. So the derivative of the big thing was 15x to the fourth. Now let's see if that equals the two derivatives multiplied. So that's going to be 9x squared times 2x. Okay, well let's see, 9x squared is 18 and x squared times x is x cubed. Well, just a minute. So 15x to the fourth, does not equal 18x cubed. Okay, wow, that's problematic. So they're not equal, so it means that there's something else going on here. In general, okay, the derivative of a product or product rule is this. Okay, so the derivative of the two functions together is f times g prime plus g times f prime. Okay, then Leibniz notation is below here, and let's just get to the English part. Okay, the derivative of a product of two functions, okay, is simply the first function times the derivative of the second plus the second function times the derivative of the first. So let's go back up here. So the first function times the derivative of the second plus the second function times the derivative of the first. Okay, really order doesn't matter. You could go second times the derivative of the first plus first times derivative. It doesn't matter, but usually we say it like that: first times derivative of the second plus second times derivative of the first. Okay, so let's try a few examples to see how this is all going to play out. All right. So, the first one is I want you to expand this multiplication of binomials, and I want you to use the sum rule. Okay, so we're going to FOIL this. Okay, so that's going to be 12x to the fifth plus 3x to the fourth. Okay, then that one, so that's going to be 8x to the fourth plus 2x cubed. Okay, the x to the fourth, the middle terms combined, so our y equals, okay, so that's going to be 12x to the fifth plus 11x to the fourth plus 2x cubed. Okay, so we multiplied that out, and now we're going to take the derivative using the sum rule, which we just used last time. So the 5 comes down, 5 times 12 is 60x, and then the exponent decreases by 1, okay, plus 44, so 4 times 11, 44x cubed, plus 6x squared. Okay, so that's the derivative of the first, or example 1a there. All right. So basically, what's going to happen in B is now I want you to derive the same thing using the product rule, and we're going to compare the answers just to make sure that we're on the level. Okay, so remember product rule Okay, so it is the first function, so the first bit, 3x squared plus 2x. So the first times the derivative of the second. So the derivative of the second is, okay, so 3 times 4, so that's 12x squared plus 2x. Okay, so first derivative of the second plus the second, so 4x cubed plus x squared, so that's the second function, times the derivative of the first. So that's going to be, okay, 2 times 3 is 6, so 6x plus 2. Okay, so again, this is the first derivative of the second plus the second derivative of the first. Okay, so that's the idea. Now we have a little bit of FOILing, a little bit of binomial multiplying to do here. Okay, so, all right, so let's see, y prime, that's going to be, okay, 3 times 12, so 36x to the fourth plus 6x cubed plus 24x cubed plus 4x squared. So that's the first bit. Okay, then this plus sign is going to go down, so plus. Okay, then we FOIL the second part. So 4x cubed times 6x is 24x to the fourth plus 8x cubed, that's that one. Okay, and then plus 6x cubed, so that's that guy, and then plus 2x squared. Okay, so that's that part. Now, of course, we need to combine our like terms. So y prime, so the 36x to the fourth goes with the 24x to the fourth, so that makes 60x to the fourth. Okay, now we do the cubes. So 6x cubed, 24x cubed, and 8x cubed, and 6x cubed. So that's 30, 38, and 6 makes 44. 44x cubed. And then we have 4x squared and 2x squared, so that makes 6x squared. So if we have a look at that, this guy and this guy are exactly the same. So we got the derivative the same way using both the sum and difference rules and the product rule. So we just wanted to prove that that would actually work. So that is fantastic. Number 2. So find dy dx if y equals root x times all of that using the product rule. Okay, so now there are some rules or guidelines that I need you guys to follow when you're using roots and x's on the bottom, that kind of stuff. Okay, the first of which is we're going to write everything as an exponent. Okay, so the root x part, we're going to turn that into x to the 1/2. Okay, and that 1 over x part, we're going to turn that into x to the -1. That's going to make things easier for us later on. So we're just going to do that right off the top. So we're going to say that y equals x to the 1/2 times 2x cubed plus, well, it's going to be 1x to the -1, so we don't even write that first one, so just x to the -1. Okay, so please we're going to do that first step all the time. And later on, we might choose to put the negatives and the fractions back in, but we'll get there. All right, so anyway, so if I want y prime then, okay, that's going to be first derivative of the second. So that's going to be 6x squared. Okay, and that -1 comes down, so that's going to be negative and -1, but we won't write the 1. Okay, so negative x to the -2. Okay, plus, so first derivative of the second plus second, so 2x cubed plus x to the minus 1. So first derivative of the second plus second times the derivative, the derivative of the first. So let's see, if the derivative of the first, so that guy, the half is going to come down in front. So that's going to be times 1/2 x to the, okay, so then 1/2 minus 1 is negative 1/2. Okay, so remember we decrease the exponent by 1, so half minus 1 is negative 1/2. Okay, so now that we have that, now we're going to do some simplifying. Okay, so this is going to rainbow in, or distribute in. Okay, and remember when we multiply same base powers, we add exponents. So the 6 is going to be by itself, and then 1/2 plus 2 is 2.5, or 2.5, or 5/2. So this is going to be 6x to the 5/2 minus, okay, so there's no coefficient, so it's just going to be minus 1. Okay, and then x to the 1/2 times x to the minus 2. So we're going to have a 1/2 minus 2 for the exponent, so that's negative 1.5, which is negative 3/2. Okay, so that's the first part, plus, okay, now we do the second part. Okay, so the 2 multiplies the 1/2. Well, 2 times 1/2 is just 1, so the coefficient cancels there. Then x cubed times x to the minus 1/2. Okay, so that's going to be 3 minus 1/2, or I guess 3 plus negative 1/2. Okay, so that's going to be 2.5 again, or 5/2. So x to the 5/2. Remember the 2.5 made a 1, so we can write that 1 if we really want. We don't have to. Okay, and then the second distribution there, so the coefficient is a 1, so 1 times 1/2 is 1/2. Okay, and x to the minus 1 and x to the minus 1/2, so the exponents just add. So negative 1 plus negative 1/2. Okay, well that's negative 1.5, or negative 3/2, so x to the negative 3/2. Okay, so once we have that, now look guys, this is kind of interesting. 6 to the 5/2, there's 6x to the 5/2 and 1x to the 5/2. So our derivative here is 7x to the 5/2. Those are like terms, they have the same exponent. And then we have a negative x to the negative 3 over 2, and the positive 1/2 x to the negative 3 over 2. Those are also like terms. So that's a negative 1, right? So negative 1 plus 1/2 is negative 1/2 x to the negative 3/2. Okay, so that is certainly an acceptable answer. Okay, some textbooks, some profs, some teachers are going to want you to turn that back around into radicals and negative exponents on the bottom, sort of thing. So if we were to do that, let's see. Remember, the bottom of the fraction for an exponent is the root. So this is going to be 7 root x to the 5th. Okay, minus, okay, so then 1/2, so 1 over 2. Okay, now remember, a negative exponent just denotes that it's on the bottom, so this is going to be a square root of x cubed on the bottom. Okay, now that looks a little weird, so we could put the 1 kind of in the middle there, but that's the idea if you had to have positive exponents and putting it back into radicals. Okay, so that's that one. Remember, the bottom of the fraction is the index on the root, so that's like that little number there. We don't write the 2 there usually for square roots. For cube roots and fifth roots and stuff like that, we put the numbers there, like always. But okay, and then the top numbers are just always on the variable. Okay, so that's that. All right, so number 3. So find the slope of the tangent to the graph of the function at the point 1, 5. Okay, so that is the derivative. Okay, slope, derivative, fairly straightforward. So we want f prime of 1 is what we're looking for. Okay, so I'm telling you what, let's find f prime of x first, and then we'll substitute 1 in. Okay, so this is going to be first derivative of the second plus second derivative of the first. Okay, so first is this. Okay, and the derivative of the second is just 6x squared. Okay, plus, okay, second, so 2x cubed minus 1 times the derivative of the first. So that's going to be 4x. Okay, so there's our derivative. Now, there's a couple of schools of thought here, everyone. If you were asked for what's the equation of the slope of the tangent line, I would probably expect you guys to simplify this out and see what happens. Right now, because it just wants the slope, technically we could just put 1 into all the x's and get a number. So tell you what, I want to set us up for success later. So even though we can just put x equals 1 in, let's distribute these things and combine all the like terms, because that is going to be a thing later. Okay, so if we distribute that, so we're going to get 12x to the 4th plus 18x squared. Okay, and then this one is going to be plus 8x to the 4th minus 4x. Okay, so then we're going to get 20x to the 4th plus 18x squared minus 4x. So there's our derivative function. And again, we didn't necessarily need to do that for this particular question because it just wants slope, but I know that this is coming up, so it's not a bad thing to practice. Anyway, so then of course we want f prime of 1. Wow, that's a terrible one. Okay, so f prime of 1. Okay, so that's going to be 20 times 1 to the 4th plus 18 times 1 squared minus 4 times 1. Okay, well, 20 times 1 to the 4th is just 20, and then this is going to be 18, so 20 plus 18 is 38, minus 4 is 34. So the slope, the f prime at 1, okay, that's the slope, is 34. Okay, positive 34, so that's awesome. You know what? Hey, let's take this even one step further, because you know this is coming too. So what's the equation of that tangent line? So if we really wanted the equation of this thing, well, it would be y minus 5 equals 34x minus 1. Again, that's not necessary for this question, but it's a nice extension, and you know that's coming too. So anyways, that's it for this section. Thanks, guys. Or this part, I guess. Thanks.